Alright, we're going to be talking about phase difference. Now, phase difference describes the difference between the displacement of particles along a wave or the difference between the displacement of particles on different waves. Now, it can be measured in degrees or radians. Now, let's look at here. So, I have two different papers with the waves on the paper. Now, suppose you have two waves that are on top of each other. So here the phase difference could be 0 because they line on top of each other. Now supposing the one at the back is moving along, and now we have something like this. Now can you see that the wavelength is here to here, so from there to there is one wavelength. So if you look at the wave behind the first wave, can you see one's in between the other one? So now can you see that the peak and the trough, well, the peak is the top part and the trough is at the bottom. If you were to add them together, they will be 0. So in this case, you can say it is destructive interference. So now here, the phase difference is 180 degrees. Now what happens if we move this wave here now? So now the phase difference here, it is 0 or 360. So here again, the phase difference is 0 or 360. If I move back here, can you see that the wavelength is half of, can you see that the distance between is half? If we, okay, so let's just have a look at that. So here, the lines, the vertical lines show the wavelength. Similarly here. So here, let's just recap. So here, the phase difference here is 0. Here, the phase difference would be 180 degrees. And here, if it moves a distance of one wavelength ahead of the first one, the phase difference here, you can see that it's 360 or 0. Let me just try to line that up properly. So it's about here, isn't it? Now what if we have the same wave? So if you look at here, so here you got A as the peak, E is the peak, the trough is C, the trough is C, the lowest part of the wave, and B and D is the equilibrium position. So what is the phase difference between A and E? So A and E is one wavelength difference. So the phase difference there would be 360 degrees, 360. Because like I said before, if I have the first wave here, this is the first wave, and we line that up. So here, the phase difference here would be 0. And so this will be A. And if it moves ahead one wavelength ahead, that point coincides with E. So it's moved 360 degrees ahead, you could say, or one wavelength ahead. So from A to E, it is 360 degrees. Now what about between C and D? Now between C and D, I think if it's symmetrical, it's a quarter, isn't it? It's a quarter between A and E. It's a quarter. So what's a quarter of 360? It's 90. So between C and D, the phase difference is 90. And what about between C and E? Between C and E, it is halfway between A and E. So half of 360 will be 180 degrees.